Welcome to SysSketch. Today we're breaking down object-relational mapping, the translation layer that lets developers work with databases using plain objects instead of writing raw SQL by hand. Whether you're using Django, SQLAlchemy, Hibernate, or Prisma, they all share the same core idea. Let's build a clear mental model of how this works. Every application that stores data faces the same problem. Your code thinks in objects, but your database thinks in rows and tables. When you create a user object in Python, you might set a name, email, and role as simple attributes. But storing that in a relational database means writing an insert statement with parameter binding, and reading it back means writing a select with a where clause. These are two very different mental models, and the friction between them is called the object-relational impedance mismatch. Object-relational mapper, or ORM, is a library that bridges this gap. It maps your classes to database tables, your class instances to rows, and your method calls to SQL queries. Instead of writing SQL yourself, you work with normal objects, and the ORM generates the right SQL behind the scenes. The core idea is, define your data model once in code, and the ORM handles both storing and retrieving it from the database. The three main layers are your application, the ORM in the middle, and the database on the right. The foundation of any ORM is the model class. You write a Python or Java or TypeScript class that inherits from a base class provided by the ORM. Each attribute you declare becomes a column in the database table. You specify the data type, constraints like nullable or unique, and default values. The ORM reads these declarations and knows exactly how to create the schema. When you run a migration command, the ORM generates the create table statement for you. Change the class, regenerate the migration, and the schema updates accordingly. Querying data through an ORM feels like calling methods on your objects rather than writing SQL strings. To get all active users, you call something like user.query.filter that generates select star from users where active equals true. To get a user's posts, you might write user.posts.all that becomes select star from posts where author id equals the user's id. The ORM builds these SQL strings safely, using parameterized queries to prevent SQL injection automatically. You can chain filters, apply ordering, limit results, and paginate, all through a Fluent Method API. Relationships are where ORMs really shine. A one-to-many relationship, like one user having many posts, is declared with a relationship field pointing to the post model. Once declared, accessing user.posts gives you a Python list of post objects. The ORM handles the join or separate query automatically. Many-to-many relationships, like posts having multiple tags, require a join table in SQL. The ORM manages that join table for you. You just declare the relationship, and the ORM generates and manages the intermediate table. As your application evolves, your database schema needs to change too. ORMs solve this with migrations version files that describe each schema change in order. When you add a new column to your model class, you run a command like alembic revision --auto-generate. The ORM detects the difference between your current schema and the new model definition, and writes the migration file for you. Running alembic upgrade head applies all pending migrations in sequence. This means every developer and every deployment environment applies the same changes in the same order, tracked in version control. ORMs are not without trade-offs. The most common pitfall is the n+1 problem. If you fetch 100 users and then access each user's posts inside a loop, the ORM runs one select for the users and then 100 more selects for the posts, one per user. The fix is eager loading. Tell the ORM to join the posts in the original query using joined load or prefetch related. When you need complex analytical queries, bulk inserts of millions of rows, or database-specific features like window functions, raw SQL is often faster and clearer. Good ORMs let you drop down to raw SQL for these cases. Every major programming language has at least one mature ORM. In Python, Django ORM is built into the Django framework and pairs tightly with its admin panel and migration system. SQLAlchemy is the most powerful Python option, offering both a high-level ORM and a lower-level SQL expression language. In Java, Hibernate implements the JPA standard and is widely used in Spring Boot applications. TypeScript developers use Prisma, which generates type-safe database clients from a schema definition file. Ruby on Rails includes active record out of the box. Go has GORM with a chainable query API. Despite the language differences, all of them follow the same core concept: classes map to tables, instances map to rows, and methods map to queries. The key insight of object-relational mapping is simple. Your application already organizes data as objects, so your database access layer should match that mental model rather than forcing you to switch contexts constantly. Use the ORM for standard CRUD operations, reach for raw SQL when query complexity demands it, and always watch for the n+1 problem in your query logs. Once you understand these fundamentals, any ORM in any language will feel familiar. Thanks for watching.